Okay, I wanted to share with you guys a little bit more on Lab 3. We talked a little bit about in the beginning the difference between message queues and well-known FIFOs. And the biggest thing to think about in this previous week is how you would send data back and forth, being that it's half duplex, meaning you can only send one way and then you have to receive a different way. So the idea between both of them is exactly the same, but we have to understand what this whole concept of rendezvous means, which is, basically where is something. So the well-known piece of this in both of these is that a message queue is defined by a key. And so we saw that with that message key and defining that. So pick an integer like 50, and that defines what we technically call it a bulletin board, and that's gonna be what you're going to use as the place. The well-known FIFO is going to be the actual name of a file. So pick a common name like /temp/server, and that's going to be the well-known place. And so both of those things are going to be where the server resides. And when you use a message queue, again, this is going to be a little bit more of pointers. And so if you don't like that, jump into the message queues, which isn't devoid of pointers, but it's a little easier to kind of understand back and forth. Is you're going to have a server, piece of code that starts up, and the server is going to basically sit there and do a few things. And so let me pull this up here to give you an idea in kind of pseudocode what again that would look like. So pretending you're down in your code somewhere, and I'm just going to kind of explain what it's going to do. Is the server code is basically going to fire up, and the first thing it is going to do is, and I'll take the message queue example, is it's going to have to basically set up that place. So you're going to do, and I'll show you again how to understand some of this. So in man pages, find it here. Let me get onto a Linux machine, that's why. Give me 1 second. Okay, let me pull this into space here. You can kind of see everything. Okay, so the first thing we want to do is our message get. So make sure you got these included. Again, for the whole concept around this is we're going to have to define this key. And the key is going to return basically our handle. I think they even have an example down here you can kind of use. No, I guess they don't. But message get is where you're going to start, and that kind of defines the setup. So if I go to this piece of code here, and I say server code, if I'm going to do message queue, the first thing I'm going to do is I'm going to have some key T type that I'm going to set up, and then I'm going to say message get key, and then your other argument there, and we're good to go. So that's going to be on the server side of things. Now, if I'm doing a well-known FIFO, then what I'm going to do is I'm going to do something a little different. So what I'm going to be doing is I have to use a function to actually go create a FIFO. And so it's actually called make FIFO, and I'm going to give it some name, and then I got some arguments that I'm going to maybe pass to it or no. And then by doing that, the one thing that I've got is this creates it. I need a handle, so I might have my handle there. And then what I'm going to do here is I'm going to have a file descriptor, and I'm going to call open with certain things. So that's kind of how I get things started with both of them. And this again is on the server. Now the server is going to, its job is just to receive messages, and then once it receives a message, it has to rip the pieces of the message out to know how to send it back. So that's that rendezvous problem. So as I look at both of these, and I'm giving you 100% here, so you got a little work to do here, but in this example, what I'm going to do is I'm going to do a message receive. And that's going to be my blocking call that I'm going to do. Over here is I'm going to basically do a read from my file descriptor into a buffer, for a certain size, whatever the rest of the arguments are. And both of these are blocking calls. So these are going to sit here and they're going to wait. That's their job. That's the only thing they're supposed to do. So as I look at these, and again, if I was to do a man on message receive, I spell it right. Notice how many things it has. It has my QID that I just created. It's got a message that's where the message is going to go, the size of that, the message type I want to listen for, and a flag. So as I look at these, and I'm just going to cut and paste this in here. And just so I don't forget anything in here. So I know that that's what I'm going to want to do. So in my message receive, obviously I'm going to test it. So I'm going to have I'm going to basically put message Q, which is my ID. I'm going to have my message here, my size of message. I'm going to have this long message type thing here, and because I'm reading it, what I want to do is this has to identify who I am. So much like we had temp server down below, I have to define who I am, and since we're going to use process IDs as a unique value, I know that nobody else can be one. And then if I want to give a flag or null. So this is kind of the trick, is to add as message type, because when you're sending it back, you're going to send it back to a given process ID, which might be 304 or 1026 or whatever. So this is your way to kind of figure that out. Now the only thing we haven't talked about, and this is where this whole thing of the message comes into play, is you're going to have this whole structure of message that's going to basically have two things in it. So it could be a message, and this is what everybody always does, so I'm just going to kind of copy. And so that's my message. And because I'm reading into this, I'm just going to give you a couple of tricks here. I have to read it in the memory address of, and I have to know the size of it and all that. But once I'm done with this, now what I have is I have the message, and then I also have the M type, which I can use to identify and send back. Now, what's going to be in the message? Oops. I'm getting a little ahead of myself here. Hold on. Is as an example, so message could be something like a string colon and then the process ID. And now you have to strip that apart, and you have to know that when you call message send, you're going to have to fill out this M type on the way out in here. So you're going to create a brand new message, which you can just copy this message and put it in that one. So you might have a structure of a message, and you might have input, and you might have output. So this one is going to change to input, and it still says a message. And then when I strip this whole thing apart, what I'm going to basically say is output dot message equals string, and output dot mtype equals 204. Now, obviously I'm paraphrasing that, but that's how you get the server thing started up and you make it run. On this, it's a little easier because all I'm really doing is I'm doing the same thing, but the message could still be the same. So the message in buff equals string 204. The only difference here is when you're going to send this back, what you're going to have to do is you're basically going to, know that your message is going to be string, and then the PID is 204. So what you're going to do is you're going to open a file that's going to be something of the nature of temp client dot and then 204. So you're going to have to concatenate that together, knowing that this part could be static, and then the 204 is the dynamic thing that comes from there. So you're going to open that, and you're going to basically write to client FD, whatever that would be, string. Now, there's a couple things that I talked about that I just want to make sure we understand as well. Is one of the keys to all this is non-blocking. So in the assignment, it talks about non-blocking, and the thing that's key to it is from a non-blocking perspective, you only non-block from the non-server side. And then there's two server sides, keep in mind, right? Because this thing blocks, this is all that this thing should do, right? So this does a message receive, it's blocking, which this is where these flags are. But if I go down here, I might say message send, message queue, I'm going to send output, memory address of output, size of, and then the flag is going to be something like, let me look it up here. Let me find the flag. IPC no wait. There it is. So that's the flag you're going to want to do. And I think it's something like that. And this is key because if the server's always there to do that, what happens if I'm trying to send this back to the client and I send this, but I do have wait on, is I could wait forever and I could deadlock and kill my code. So this is kind of key on both of these. The same thing here, when I open this client, one of the things I'm going to do is send the O non-block in there. So that's just one of the criteria that has to be in there. Now, this is setting up the server. Now, the client's perspective has to kind of do the same things, but they're just kind of doing it backwards. So when the client starts up, they're going to do a message send, and they're going to send to mtype of 1 and a message, which is going to be this string when it finally comes. Same thing here is I'm going to open up, and you got to be a little careful. You have to open up your own client before, make all that stuff done, and then you're going to send to the server and then read. So that's a little bit of kind of pseudocode in what we talked about last week. As it pertains to the assignment, that's this kind of section here. The thing we didn't talk about is the threads and the semaphore. Now, to make it very simple, what I did here is I created this thing called thread listener that just loops forever. And this thing, basically what it does is it requests the semaphore, it locks it, reads it from the queue, does whatever it's supposed to do, responds to client, and then goes back. You can use this code, but keep in mind that really what I'm saying in all of this is an example where, I'll just go down here. So I have a thread listener function, and in here I can just say while 1. I loop forever, knowing that that'll end that. And then what I'm doing in here is I'm using semaphores, and I'll let you find the actual code to make all this stuff work, but I'm asking the semaphore, so basically I'm getting to this point of doing a lock. If you get the lock, then basically what you're going to do in this is you're going to go back. So if you see example here, I'm looping forever, I'm requesting it. Once I get it, which is part of this, you'll see then I'm going to do my read or my message receive. And then once I come out of that, I unlock, which this is pseudocode. This isn't exactly what's in there. And then I can go do some more work because I've read that, but now I need to respond. So, you know, open and write to client. And that's that. Now, this being what I call a thread listener, this gets you the semaphore piece of it, but we need to start this thread listener. So what you're going to have in your main code is you're going to have all your setup stuff, you know, int fd equals 0, blah, 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 all your other stuff. And then somewhere down there, you're going to have pthread create thread listener. Oops. And let me look at the prototype for that. So it's the attribute set. You don't need to do everything in here. I think I can find a quick example. So here's thread start. Oh, okay. That was the one thing I was missing. So here's an example, so you can even see it in there. This is not a fancy thing. I'll just show you how to do this really quick. This we're going to make null, and this we're going to make null. So what we'll basically have is the function itself, the memory address of the function itself, and then a thread ID, and I just want to go see, I think it's just a TID. Thread info. Pthread T, okay. So what you're going to have is pthread T, TID, and that goes here. Then you're going to do null, and then you're going to do, basically, you're going to say, you got to say the memory address of thread listener null. Now, I'm not giving you all the pieces of pthread create, and there's a lot. You should be doing attribute sets and all the other fun stuff. We're just using it to kick off 3 threads, and the way you kick off 3 threads is you just have 3 lines. So what this will do is this will start this, and so the reason I'm showing you this now is I want you to think about putting everything of this work that we had up here down here in the actual thread listener, or whatever you want to call it. The thread ID is just this unique ID. You do need to test it. There's a couple other things around there, but this should get you enough to really make it work. So that's the piece on the assignment that gets this idea that you're going to start 3 threads, and at any given time, because of the semaphore, you're only going to have one of them running. Now, you should be doing a pthread mutex lock if anybody knows what I'm talking about or has that question, but I'm doing this very purposeful, so you'll get to test. You get to write code against a semaphore, you'll get to do one against threads, and you know, it all kind of fits in this whole thing with the IPC piece. So that's the second piece of it. But again, any questions, please contact me.